In this section, we're going to learn two new rules, the product rule and the quotient rule. So for the product rule, this starts when you want to take the derivative. Remember this, d over dx says take the derivative. But you have two functions, f of x and times g of x. Now you're multiplying them. You could, in theory, FOIL them out and expand and simplify, but sometimes that would just be too difficult, especially if we have really complicated looking formulas. And so we have an actual product rule, which is if you have the first function times the second function, then the derivative will be, and now it seems fairly complicated here, you have to do the first function times the derivative of the second function, plus the second function times the derivative of the first function. It doesn't get any simpler than that, it's just you have to go through piece by piece and be very careful. So in this example, we want to find the derivative. Notice I have x squared minus 3x quantity times the quantity square root of x times plus 7x to the fifth. Okay. Notice when you look at this, you'd have to actually FOIL it out and simplify. Probably more work than we want to do, so we want to use the product rule. So this derivative, so this piece will be our first function, and this will be our second function. So the derivative, we're supposed to find the derivative of it, is going to be, you just follow this formula, so put the first function. So exactly like it is, don't change it, x squared minus 3x. Okay, that's our first function. Times the derivative of the second function, so derivative of the second, so derivative is square root of x. Now if you don't remember, x can be written as 1/2. Okay, so we're going to bring down the 1/2, x to the negative 1/2, drop the power by 1, plus 7 times 5x to the 4th. So we took the derivative of the second function, plus our second function, which was this entire square root of x plus 7x to the 5th, times derivative of the first function. Your first function is x squared minus 3x, so that derivative would be 2x minus 3. Okay, at this point, you could go through and simplify. You'll have to check on MyMathLab. Some problems will make you simplify more than others. This is probably more simplifying than I really want to do then, though, and I would probably try and stop here, unless I'm told that I have to simplify further. Okay, so once again, this was our first function. This was the derivative of the second times our second, or plus our second times the derivative of the first. Now this is the product rule, and so if you switch which one you write first, it doesn't necessarily matter as long as you pair them together correctly. So you need the first and derivative of the second together, and you need second and derivative of the first together. As long as you do that, you'll be okay. And then we have a quotient rule. So just like when we have a product, when we multiply two things and we can't simplify it, you often have a division that you can't get rid of. So we want to take the derivative, and we have an f of x over g of x. So you're dividing two functions. For me, this is a lot easier to think of it as top and bottom, even though that's not technically very technical. Then the derivative of this quotient will be your bottom times derivative of the top, minus the top times derivative of the bottom, all over the bottom squared. This one, it does matter. Make sure you put pieces in the right order, in the right places. So let's try example 2 using our quotient rule. So you'll see when you look at it, we have x plus 2 over 5x squared minus 3. There's no way to simplify this or get rid of the division. So I say, okay, this x plus 2 is my top, 5x squared minus 3 is my bottom. And we just go ahead and plug everything into the formula. Okay, so f prime of x, or the derivative of f prime of x. Now this is confusing because we also have f primes up here. And so sometimes instead of that quotient rule, I actually prefer to say, okay, the derivative of top over bottom is equal to bottom times the derivative of top minus the top times the derivative of the bottom over the bottom squared. That way I don't have to worry about the fact that this actually said f of x, but f of x for my formula is just the top, etc. Okay, let's see. So it says do your bottom. So my bottom is 5x squared minus 3 times the derivative of the top. My top is x plus 2, so that derivative of that is just 1. minus, make sure you do a minus. The top now says do just the top, don't change anything. So all of x plus 2. Times now the derivative of the bottom. The derivative of the bottom, derivative of 5x squared minus 3 is just going to be 10x. All over the bottom squared, so you don't change anything or do anything, you just write the bottom and then square it. And that would be our answer. You could probably simplify this one fairly easily, but I'll let you do that on your own time. As far as using the quotient rule, again, just make sure that this is a minus and make sure you put the bottom and top derivative first, because the order here doesn't matter because it's a subtraction and not an addition. Now, sometimes you'll have multiple step problems. Sometimes you'll have a product rule inside of a quotient rule and you just have to be very careful, do it one piece by one piece. Sometimes though, they'll have you do the general power rule. So remember when you have your composition of functions? And this is when I drew like a box. Okay, so this was for something simple like 5 plus 2x to the power of 10. And so we said, okay, we'll come through and we'll draw a box around this. And then to find the derivative, you do derivative of the outside times derivative of the inside. And so in this case, if you had this situation, you would bring down the 10, keep everything in the box the same, and drop your power by 1. So everything in the box is 5 plus 2x. Times, and then derivative of what's inside the box. 5 plus 2x, that derivative would be 2. So if you don't remember this, and go back and look at section 1.6, when we learned about the general power rule. So this, from here to here, is the derivative of the outside. And this is our derivative of the inside. So that's just a quick reminder of what our general power rule does. Okay, so we're going to do two examples where we have the general power rule mixed in with our quotient rule or product rule. So find the derivative for y equals 7x over 5 plus 2x to the power of 10. Okay, notice we need to use a quotient rule. This is a quotient. So 7x would be our top, 5 plus 2x to the power of 10 would be our bottom. So the derivative, if you have a top over bottom, I like top over bottom better, is you do the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That just looks so much simpler to me. So, in our case, the derivative of y is we want to do the bottom. So that's 5 plus 2x to the power of 10 times the derivative of the top. So derivative of the top is 7x, so that derivative would be 7. Minus the top, which is 7x, times the derivative of the bottom. So derivative of the bottom, oh, that's why I needed the power rule for this 5 plus 2x to the power of 10. I needed to find the derivative of it. And so inside my quotient rule, I kind of stop. I go off to the side. I say, what would that derivative be? So I had to use my general power rule, but I finally figured out it says 10 times everything times 2. So let's simplify that to 20 times 5 plus 2x to the power of 9. All over my bottom squared. So 5 plus 2x to the power of 10, and then I square all of that. In example 5, let's find this derivative for the square root of 5x minus 2 times x to the power of 4 plus 1. So this one, this square root, we actually need to do the general power rule. First. So I'm going to rewrite this as 5x minus 2, x to the power of 4 plus 1. And all of that is raised to the power of 1/2. That's what the square means. So I have this big power around everything. I can't do anything until I get rid or deal with that 1/2 power. And so we need to use the general power rule. And so I say, okay, I have kind of a box inside of here. And so the general power rule says that you're going to take the derivative of the outside. So you bring down the 1/2, keep the box exactly the same, and drop your power by 1. So what goes inside the box still are 5x minus 2 times x to the 4th plus 1. Then we have that raised to the power of 1/2, negative 1/2. Times, now you do the derivative of what's on the inside. So derivative of what's on the inside, now for this piece, we need to use the product rule. Okay, and the product rule says we'll do f times g prime plus g times f prime. So let's try this out. So f is our first one. So 5x minus 2, you keep it the same, times derivative of g, derivative of the second one, which is 4x cubed plus 0, plus, keep your second one the same, x to the 4th plus 1, times the derivative of your first one. Derivative of 5x minus 2 is just 5. Okay, so we had to do a few different things here. So this is the derivative of the outside, and this is derivative of the inside, but we had to use the product rule. So the product rule and quotient rule, they take a few tries to get familiar with it, but then we add complexity by making you use multiple steps. You just have to be very slow, very careful, label your work, and make sure you don't get lost.